You ever watch a sci-fi movie and just wonder, okay, how much of that is real? Well, today we're tackling one of the biggest ideas out there, time dilation. Is it just a cool trick for movies, or does time actually bend in real life? We're going to break it all down, and our guide for this journey is a fantastic physics report by student Shreejan Sapkota. Let's dive in.
So, let's just start with the big one. The question that fuels movies like Interstellar. Can time, actually slow down or speed up? We tend to think of time as this constant thing, right? It just ticks forward, second by second, for everyone everywhere. But what if it doesn't? What if time could tick slower for you than for me? Well, according to the actual laws of physics, the answer is a mind-blowing, definite yes.
Right, so this whole idea has a name, time dilation. And as our source report lays out so clearly, it's really just the difference in time measured by two separate clocks. And this difference isn't random, it's caused by two very specific things: how fast you're moving and how strong the pull of gravity is where you are. But to really get why that is, we've got to talk about the genius who figured it all out.
To wrap our heads around how time itself can bend, we have to talk about the man, the myth, the legend, Albert Einstein. His theories of relativity didn't just tweak physics, they completely revolutionized our understanding of the universe and gave us the rulebook for how time dilation works.
Okay, so Einstein's big idea really comes in two flavors. First up, you've got special relativity. This one's all about speed. The faster you travel through space, the slower time passes for you compared to someone standing still. Then there's general relativity, which is all about gravity. The stronger the gravitational field you're in, the more time itself gets stretched out and slowed down. Two different causes, but they both lead to the same bizarre result.
And here is the absolute key to all of this. Space and time? They're not two different things. They're actually woven together into a single fabric called space-time. The best way to picture it is to think of a giant trampoline. Now, if you drop a heavy bowling ball right in the middle, see how it creates that big dip? That's exactly what massive things like planets and suns do to space-time. And everything else, including light, has to follow the curve of that dip. Time itself gets warped right along with space.
But here's the thing. Einstein didn't just dream this up out of nowhere. No way. He was, as the saying goes, standing on the shoulders of giants. He was building on centuries of scientific questions and discoveries that really paved the way for his huge breakthrough.
This whole thing was like a massive puzzle being put together piece by piece over hundreds of years. It really started way back with Galileo thinking about motion. But the real game changer was when Maxwell's equations showed that the speed of light is always the same. It's a constant, no matter how you look at it. That one single fact was the key that unlocked the entire puzzle for Einstein, leading directly to his world-changing theories. It's just an amazing story of how science builds on itself.
Okay, so theory is one thing, right? But how do we actually know this isn't all just some wild math on a blackboard? Well, this is where it gets really, really cool, because we have stone-cold proof.
So check this out. Back in 1971, two scientists, Hefele and Keating, had this brilliant, almost simple idea. They took these incredibly precise atomic clocks. We're talking clocks that are accurate to a billionth of a second. And they put them on regular commercial airplanes. They flew them around the world, one going east, one going west, and they left one behind on the ground as the control. The mission? Just see if the clocks would still agree when they all got back together.
And what they found was absolutely incredible. When they brought all the clocks back into the same room, they were out of sync. The clocks that had been flying had literally experienced less time than the clock that stayed put. Now, we're talking about nanoseconds here, a tiny, tiny fraction of a second. But it was exactly what Einstein's math predicted would happen. Time dilation wasn't just a theory anymore. It was a measurable, proven fact.
Okay, so a few nanoseconds on an airplane. Who cares, right? Well, it turns out this weird little glitch in the universe isn't some abstract thing at all. It actually has a massive impact on technology that you probably use every single day.
Just think about your GPS, the one on your phone. It only works because it's talking to satellites that are zipping around the Earth at thousands of miles an hour. Now, because they're moving so fast, special relativity says their clocks should tick slower than ours. But they're also way up high in weaker gravity, so general relativity says their clocks should tick faster than ours. It's this constant tug of war. And if the engineers didn't calculate and correct for both of these time dilation effects constantly, your GPS location would be off by about 10 kilometers every single day. The map on your phone works because we know time is relative. It's amazing.
All right, so we've seen it working right here on Earth. Now, let's push things to the absolute limit. Let's go cosmic and see where the rules of time get pushed to their breaking point.
Imagine gravity so intense, so powerful, that it literally punches a bottomless hole in the fabric of space-time. That's a black hole. And if you get close to one, time starts to do some very, very strange things. The closer you get to its edge, the event horizon, the slower time moves for you. If someone were watching you from a safe distance, they would see you appear to slow down and eventually freeze, stuck in time. It is the most extreme example of time dilation you can possibly imagine.
And this, of course, brings us full circle, right back to the sci-fi stuff with the idea of a wormhole. As our source report explains, this is a totally theoretical concept, a shortcut through space-time. But if a stable one could exist, it wouldn't just be a bridge between two places, it could potentially be a bridge between two different times.
So, when you boil it all down, it really comes back to this one simple but profound idea from the report. Time is not a universal clock ticking away for everyone at the same pace. The speed of your clock, the rate you experience life, literally depends on your speed and the strength of gravity around you.
Which kind of leaves us with this one last giant thought. Just a little over 100 years ago, the idea that time could stretch and shrink was completely unthinkable. Today, it's a proven part of how our universe operates, something we have to account for in our technology. It really makes you wonder what other fundamental rules of the universe are just out there, waiting for us to discover.